to what we're supposed to be doing today. 5.5, today is actually your work day, okay? So we're going to be hard-pressed to get through everything we need. We've only got 25 minutes. So I'll do up to 4 problems. So is there anything that you specifically want to see done? Please say so. So up first is number 8. And for this section, they're going to ask you to perform long division, okay? So can I please get the 2 functions? And remember, I have my earpiece in, so I'm a little deaf right now, so bear with me, please. Okay. Thank you. So who remembers, what's the very first thing that I need to do when I'm using long division? What's the first thing I have to check? Power, yes. Okay, so there's 2 parts, right? Is each of my functions written in standard form, and is every power represented? So up first is the numerator. What's the degree of the numerator? 3. I need an x cubed term, an x squared term, an x term, and a constant term. Do I have all 4? Yes. And is it written in that order where it's 3, 2, 1, 0? Yeah. So is everybody okay with the numerator? Okay, denominator, what's the degree? 2. So I need a 2, I need a 1, and I need a constant. So do I have an x squared term? X squared? Yes. Do I have an x term? No. So what do I add in its place? Okay, so the denominator goes outside. So I'm going to write this as x squared plus 0x plus 1. Everybody all right with that? And then the numerator goes underneath the division bracket. Is this a linear? So, yeah, so like I said, the linear, or the synthetic is great, but because it's situational, we have to have both tools. Okay? Everybody good? Yes, no, maybe? All right, so now, whatever I write up top here has to multiply with the x squared from outside, and I want it to get me the lead coefficient here, or sorry, the lead term. So I want to get 7x cubed, right? So what times x squared will get me 7x cubed? 7x, nice and easy, right? So now I'm going to take the 7x from the top and multiply it by everything outside and list my 3 terms underneath. So what's 7x times x squared? Okay, 7x times 0x. 0x squared, right? Because x times x is still there. Okay, so do you see why I want to put in the 0x? So it creates this spacer for me like I'm supposed to see. Okay, and then what's 7x times 1? 7x. Okay, so what do I do with these 2 pieces now? Do I add, subtract, multiply, or divide? So change the signs and add because we're subtracting, right? So this becomes a negative, negative, negative. And now we actually just perform the math. So what is 7x cubed? Take away 7x cubed. Cancels out. Which is, again, that's what we want to see. Every time we perform this, that first piece, that first pair, those terms had better go away. Okay? So what's 11x squared? Take away 0x squared. 11x squared. And what is 7x? Take away 7x. It cancels out as well and leaves me with a plus 0x. Okay? And then I drop the 5. So again, I'm only using the 0x here as a spacer. Okay, why didn't I put the 0x cubed here? Because it's just a 0 and we don't need a 0 in front. I'm using this 0 just to create a gap so that way as I perform my math, I don't get any weird spaces going on. Okay? So, same process. Now I want to get 11x squared. So what do I multiply with x squared to get 11x squared? Okay, so I get plus 11, right? No x's, just 11. Everybody good? Okay, what's 11 times x squared? 11x squared, 11 times 0x. 0x and 11 times 1? Plus 11. And then what do I do with these? Change the signs because we're subtracting. And what's 11x squared? Take away 11x squared. 0x take away 0x. And what's 5 take away 11? Negative 6. Okay, and what is this number called here? The remainder. So, am I done? No, you have to actually write out your full solution, okay? I want to know what is 7x cubed plus 11x squared plus 7x plus 5 divided by x squared plus 1. So, I get the number on top. So, what do I have on top? 7x plus 11 plus my remainder, which is negative 6, over the divisor. So what am I dividing by? Right. So actually what I'm going to do is I'm just going to use the original divisor. X squared plus 1. Everybody okay with that? Yes, no, maybe? So I need to see this marked somewhere on your sheet as in, hey, that is my answer. That's what your answers have to look like in this section. Okay, the polynomial plus your remainder over the divisor. Okay? Yeah, 7x times x squared is 7x cubed. 7x times 0x is 0x squared. 7x times 1 is 7x. And then you subtract. And then you drop the 5. And then you do it with the next lead. So the next lead coefficient is 11x squared. So what do I multiply with x squared to get 11x squared? 11. So 11 times x squared is 11x squared. 11 times 0x is 0x. 11 times 1 is 11. And then you subtract. So change all your signs. And then add them. The remainder is because I'm out of stuff to drop. So that's just the piece that's left over. You always add it. Yep. Always. Just like with regular numbers, when you do regular long division. Right. And you can include the 0. It won't be wrong. It's just that it's less writing. So you can always use the original or the modification because there's no difference between them. Okay? Yes. Yep. But that's just to keep my spacing. So if you notice when I multiplied, right, cubes were over cubes, squared were over squareds, x was over x. Even the next line, squared over squared, x over x, constant over constant. So to keep that nice spacing, you need the placeholders. Okay? All right, any questions on 8? Or are we good? All right, 15. The directions here say what? Use what kind of division? Synthetic. So that means that we should have a denominator that's linear. Okay? So we'll double check that as it comes out. So can I get the two functions for 15, please? Okay, so can everybody see that the denominator here is in fact linear, right? X minus 4, biggest power is 1, which means that we can use synthetic division. So this is the key. So there's two things we have to do before we can do work. Okay, so there's work we have to do before we can actually use the synthetic process. Who remembers? What are the two things we have to make sure of? Okay, we have to set that equal to 0 and get a single number to go outside in the box. That's one thing. And what's the other thing? What do we always do when we divide? Make sure that the numerator is what? In standard form. And has every what? Has every power. Okay? So anytime you do division, that's what you need to set up. Okay? Standard form, which means biggest power to smallest power as you move left to right. And every power has to be present. So if you take a look, what's the degree of my numerator? 3, right? So I need an x cubed, an x squared, an x, and a constant. Do I have all 4 pieces? No, what's missing? X. So I'm going to rewrite this as x cubed minus 5x squared plus 0x minus 2. Again, the 0x is just a placeholder, but if I don't have it, especially with synthetic, like synthetic is very, very touchy. Okay, we're talking like long division is a broadsword, synthetic division is a rapier. Okay, requires a little bit more skill to use, but it's very, very precise. So if you do not include that 0, you will get the wrong answer. It is guaranteed. Okay, you have to stick to the process for synthetic because it's very, very specific. Everybody okay with that? Yes, no? Okay. So the other thing that we need to do is take the denominator, set it equal to 0. So what is x equal to? Positive 4. Again, what do I do with this number? Put it in the box outside. So I set up for my synthetic process. The 4 goes in the box. What goes across the top row? What are they? Yeah, the numbers. What? Not constants, different C word. Starts with the coefficients. So we put the coefficients in order, okay? When I was doing quizzes and homework, some of you guys were just going with whatever order they give it to you as, okay? It's very important that you take your polynomial and put it in standard form because your powers and your coefficients have to match up when you write them. So what's the coefficient on the biggest power? 1. So that is in the lead. Is everybody okay? What's the coefficient on the next biggest power? Okay. So that is why I want to make sure that we're writing things out in standard form, because then you don't have to think about it. You can just pull the coefficients as they show up. Everybody good? Okay. And real quick, what's this? What goes in the box here? All right, remainder. So for the synthetic process, I'm set up and ready to go. This is the easy part, right? So what do I do first? Drop the 1. What do I do with this? And then what do I do with these? And then I multiply and go back through, right? Nice and easy. Okay? So real quick, if this is my final answer down here on the equal bar, and this is my remainder, yeah? Okay, you good? Okay. Because I tend to make mistakes, so like if you think something's wrong, please make sure you stop me. Yeah. So you drop the 1, right? And then you take whatever's from the bottom line and multiply it by the box. So what's 1 times 4? That goes into the second line. And then you add the first and the second line. So what's negative 5 plus 4? And then we repeat the process. So negative 1 times 4 is negative 4. 0 plus negative 4 is negative 4. Negative 4 times 4, negative 16. Negative 2, take away 16, negative 18. And now we're out of stuff, so we're done. Yes?
Where's your negative 16 from?
Negative 4 times 4. Everybody okay with what's going on there? All right, so again, if this is my answer underneath it here, and this is the remainder, what's to the left of the remainder in an answer? Right, and we keep going until we run out of stuff. So if you notice with a lot of these processes, we just kind of keep repeating the process until we're out of things to do. Okay, so that's what we have going on here. So I have performed synthetic division, but now I have to write my answer. So I'm going to take the coefficient and pair it with the variable. So what does this 1 actually represent? 1 what? 1x squared, right? Okay, what's the negative 1 actually equal to? Minus 1x. The negative 4 is just a constant, so should it have a variable on it? No, because it's just a constant, right? So it's just a minus 4. And then plus, what's my remainder? Over my divisor, x minus 4. This is your final answer. Woo! So again, for synthetic division, the actual division part where you're multiplying and adding, that's super easy, right? You guys can multiply and add all day long. Why is this tricky? Where do people make mistakes? In the setup. In the very first step. You forget a 0 here. You don't think and remember to put it into standard form. You write x minus 4 in the box instead of positive 4. Those things seem like they're small, but they will throw off everything. Okay, so synthetic division is nice because it's fast, but to gain that speed, we have to have precision in the build. Okay, whereas long division isn't nearly as fast, and it's not anywhere near as pretty, but it's something that you know how to do. You've been doing it for a long time. So 25, I should have time to get this one done, and 32 is not that hard as far as it's similar to 25, so if I can get through 25, I'll do 32 tomorrow, okay, or that problem set. So 25, can I get the f of x, please? Okay, and then it's got a semicolon, and then what? Okay. So I don't know if we didn't get all the way through the notes on this section yesterday, Monday, right? The bell rang as we were like halfway through. So I'm giving you a polynomial and I'm giving you a factor, and I want you to factor the polynomial completely. So let's look at the number 18. If I said factor 18 completely, if 3 is a factor, so that means that I'm going to have a 3 under here, right? 3 is a factor of 18. What does that mean? How would you find the other number? So what goes here? Why? 3 times 6 is 18. So another way of thinking it is I take the number divided by the factor they give me, and the result is the other piece, right? That's what I'm doing there. I'm going to take the polynomial, and I'm going to divide that by the factor. Now, real quick, can 6 get any smaller? Yeah, to what? 2 times 3. Okay, so now is it factored completely? Yes, it's a 2, 3, and a 3. Everybody okay with that over here? You guys remember this from 6th grade or 7th grade, right? Prime factorizations. We're going to do the same basic thing over here. So I'm going to take this big f of x, and I'm going to divide it by the x plus 9 because they said that's a factor. So real quick, you said that 3 is a factor of 18, right? So what is 18 divided by 3? 6, okay? It's a whole number. Is there any remainder involved with that? No. Whenever you take an object and you divide it by a factor, you must get a remainder of 0. That's actually the definition of a factor. We use the phrase, it divides in evenly. What we mean by evenly is no remainder. Everybody all right with that setup? Everybody okay with where the top row came from? Right, our polynomial was given to us with everything we needed. Any questions on the actual synthetic division? No, and because they said x plus 9 is a factor, I expected a remainder of 0. I want to multiply it out, though, to make sure, because what happens if I make a mistake here and I put the wrong number here? Will I automatically get a 0 here? No, so I don't assume it's a 0. I expect to get a 0. Now, I did write this out a little bit differently. You have to write out your factors. So I write out x plus 9 in parentheses. I take the answer from the synthetic division, and I write it as a quadratic, right? Now, can this quadratic be factored? Yeah. Two numbers that multiply together to get 12, but when you add them, you get 7. That's 4 and 3. So we set it up. So when they say factor completely, make sure you're going all the way down, please. Thank you. Have a good day. Bring questions tomorrow.